Hello friends, in this video today we will discuss about the function in Matlab. The syntax of a function is function, the output variables and is equal to the file name myfun and the all input variables. Whenever we start to write a function, we will start with this syntax line. Okay. Above syntax declare a function named for myfun that accept the input variables x1, x2, x3 up to xn and returns the output y1, y2, y3, y4, y4, y5 up to yn. This declaration statement must be the first executable line of the function. Valid function names begin with the alphabetic character and can contain letters, number or underscores. Okay. After this, you can save your function in the function file which contain only function definition. The name of the file must match the name of the first function in the file. Okay. In the script file which contains the command and function definition, function must be at the end of the file. Script file cannot have the same name as a function in the file. Functions are supported in a script in 2016b or later versions. We cannot use function in the R 2015b or A. So function can be used in the Matlab 2016b and after the version 2017, 18, 19, 20, 21. Okay. Now we see how we define a function in Matlab. We have a different examples. With the help of different examples we will first define and how to write a function. There is a first example function with one output. Okay, so we go first to the Matlab and we see how we write a function in Matlab. You can see on the screen we have opened the Matlab online and there is a file name that is a average.m. In this you can see first we define a function with the syntax function and the output variable ave is equal to the file name average and the input variable x. With the help of this function we try to find the average of any array which have a 10 to 15 numbers, and we try to find the how we can calculate the function of any given set of numbers. Okay. uh, so first we define a array x in the command window. There is a x is equal to 1 comma 5 comma 7 comma 3 comma 34 comma 78. This is a array and we try to find the average of this array. So first we define this array, and when we define this array, a variable x is created in the workspace which have a 6 numbers. Okay, now I can find the average of this x with the help of function. Now I call the function by writing the average and of what x. Now you can find that the command window responds with ans is equal to 21.3333. This is the average of this given array. Okay, so now you can see here this is the example of single input and single output function. Okay, as you see here we do not define any output variable, so this by default this the output of this function is stored in the ans variable. I can store this value to some output variable like ave is equal to average comma x. Now the whatever the value comes from the function will be stored in the variable ABE. Okay, there is another method to how we can call any function. So this is example of how we can define. Now we discuss a function which have a two output and one input. We have already write a function that name is stat.m. In this file you can see we have a two output m and s, m for the mean and s for the standard deviation of the input variable x. So whatever the input we define in the command window, this function will give the two output. One is the average of the input variable and the standard deviation of the input variable. Okay, you can see for writing this function we define a variable n is equal to the length of x, and to find the average of any set of numbers we need to find first the summation of all the numbers and the counting of all the numbers, that is n. And for finding the standard deviation of the particular set of numbers, that is equal to the square root of sum of x minus m square divided by n. That will give me the the standard deviation of a given set of numbers. Okay, now for calling this function we first define a input variable x. We define an input variable x that have a collection of numbers 1, 4, 7, 9, 34, 89 and 90, 56. This is a required set of numbers, and we try to find the average and the standard deviation of these numbers. So when I define this, now to find the average and standard deviation, I need to get these numbers in two variables like average AVE and comma standard deviation for stat STS for standard deviation, and is equal to the function name stat and input x. This is calling the invalid expression while when calling a function on indexing a variable. So there is some problem in calling this function. The problem is I cannot use the brackets like this. I can use the bracket x. Now this will give me the two variables. AB is equal to 36.25 and the standard deviation is 35.2624. So this is example of two output and single input of function. Now we go to the another example, that is stat2, where we use the function. This example of function we use the two function in a single function file, and there is a second function which is called the ABG. This is called the sum function, which is used to define the another function. Okay, and this is example of same finding the average and the standard deviation of any given set of numbers. And we define it like this. We first write the syntax line function, the output variables, and the stat2 is the file name and the input variable x, and then we find the length of the x, and for finding the average of this input variables we use the sub function m is equal to avg x comma n and semicolon. And we define this sub function at the end, as we already know in the slides that whatever we define any sub function, we need to define that function at the end of the file. So we define this function at the end, and the function m is equal to avg x comma n, and the m is equal to the sum of x divided by the length of x, that is n. Okay, now this will give me the average of the given input numbers, and this value will be saved in the m here. Now for the standard deviation, s is equal to square root of the sum of the x minus m square divided by n. So this is example of function where I define a sub function, and that sub function is called in to define the another function that is called as a stat2. Okay, so whatever the first function, the file name should be according to the first function. Okay, now to call this function, I use the same way, the average. Now I can say this av comma st and bracket is equal to stat2 of input variable x. Okay, so this will give me the same values as earlier. We get the earlier values of av is 36.25 and sts values is 36.2624. the same values I get it. The av is equal to 36.25 and st is equal to 35.2624. okay, now we go to the another example. This is an example of argument. The argument is used when I want to declare, if I give a invalid input to the function, that will give me the argument in the command window that that value is invalid or not as I need. Okay, there is a function, the file name is stat3. this is the same function is written for the finding the average and the standard deviation. So there should be the all values should be numeric or a finite number. So I use the argument command like this, argument and x1 comma colon, and if the value is not a numeric number or a finite number, the output will be, the value should be must be numeric or a finite number. Okay, the another things are same as earlier. If I give any invalid number or a non-numeric input in the input variable, like x is equal to none comma 1 comma 3 comma 5 comma 8, and I define the x like this, and I try to call this function stat3. this will give me an argument in the output that invalid argument at position 1. the meaning is the none is a invalid number. So whatever I want to check the all input is valid or not, I can use the argument command in my function file. Okay, so this is the example of argument, and now I go to the another example of how I can use a function in a script file. Okay, now you can see here the function file name is not same as the script file name. Okay, so this is an example of how I can use function in a script file. So whenever I define a function in a script file, the function should be defined at the end of the file. Okay, as you can see here, the function is defined at the end of the script file. Y is equal to my integrand comma x, sorry bracket x, and y is a sine x cube. So this is an example where I try to find the plot of sine x cube. Okay, the limit of this plot is x minimum is 0 and x maximum is pi. So this program will give me the plot of sine x cube between 0 and pi. Okay, to do this, I first define the limit x minimum is 0 and x maximum is equal to pi, and I define the my independent variable x, where I try to find the value of sine x cube. So x minimum colon pi upon 120 colon x max. Now you can see here I use the step sizes pi upon 120 to get the more accurate plot. So now I call the defined function my integrand. So y is equal to my integrand at x. Whatever the value I given to the x, this will give me the value of sine x cube. Okay, now I use the command plot x comma y. So to call this function, I can simply write area of sine and enter. So this will give me the plot of sine x cube between 0 and pi. Now you can see here, this will give me the plot of sine x cube between 0 and pi. But you can see here, I can just find the plot between 0 and pi. If I want to change this limit according to my need, what should I do? I can define this script file as a function. How I do this? I just eliminate some values here and define function is equal to y is equal to area of sine, the file name as the function file name, area of x minimum comma x maximum. So this is a method how I can find the plot as I need. So now I need to write a AND. Okay, so now this is become a example of function where I can find the plot of sine x cube whatever I giving as an input. Okay, now I need to save this file. The file is saved. So if I want to get a plot between 0 to 2 pi, how I can do this? I just go to the command window and I call this function like area of sine between 0 to 2 cross pi, and this will give me the plot of the same function between 0 to 2 pi. Now you can see here, this will give me the plot of sine between 0 to 2 pi. Okay, so this is as simple as you see here. Okay, now I can change the limit again. The area of sine between 1 to pi here, this is should be 0 to 2 pi. Okay, zero to 2 pi. Now you can see here a very clear plot of sine x cube. This is a plot between 0 to 2 pi. Now if I want to change this limit again, 0 to 3 pi, so this will give me the plot of 0 to 3 pi. Okay, this is a plot of 0 to 3 pi. So you can see here, with the help of example, we can find any computation with the help of just defining the input variables, and I can find the output variables. So function is used when if I have any function or any computation which is depending upon some variable, so I can use there the function. Okay, now I have another example of the nested function. Now I go to the another function. I have seen the function with a one output, function with a multiple output, and function with a skip file, and multi-function in a function file, a function with argument validation. We have all seen these examples. Now I go to the another. Now we discuss about the nested function. The primary difference between the nested function and other type of function is that they can access and modify variables that are defined in their parent function. Nested function can use variables that are not explicitly passed as input argument. In a parent function, you can create a handle to a nested function that contains the data necessary to run the nested function. Now we see in the Matlab how the nested function work. Now we have come into the Matlab online window, and you can see here we define a function which name is parent.m, and you can see here the function parent have a value of x equal to 6, and which displays the value of x, and after that we call a function nest fun m. This is a nested function which is defined inside this parent function. The function nest f1, which increase the value of x with a 1 increment x is equal to x plus 1, and again it displays the value of x and end. Now you can see here the major difference between the nested function and other local function and sub function is that this function is defined inside a parent function. This is not explicitly defined, and you can see here the parent function before ending of this function, the nest function is defined here. Okay, the main quality of nested function is that it can change the variable of the parent function. The meaning is it can modify the value of x by the increment of 1, the x is equal to x plus 1. Okay, now we see how this works. Now I try to call the function parent in the command window. When I call this, I get the two output, which is x is equal to 6 and 7, which is defined in the 6 is defined in the parent function, and the nested function gives the increment of 1, and I get the value of x is equal to 7. Okay, so this is how the nested function work with the parent function. Now if I want to create a handle for the nested function and how I can call the function, I will discuss in the another example. This is another example, and how I will see how the nested function work with the function handle. Okay, sorry. For this I in this function you can see here in the nested function we defined a function name is parabola x, which gives the value of y depending upon the a, b, c and x, and we get the value of y in the output function, and which is a parent function which name is main1, and I can call this function with the help of three variables a, b, c. Okay, now I try to call this function and store the value of this in the variable p is equal to main1, and the value of abc is 1 comma 4 comma 6, and I get the value of the function handle with value. The meaning is p is a function handle, and how I can call this and how I can get the value of y. I can value of y is like this, y is equal to p comma at what x I can get this. Now, and x is already defined in this problem, px, and I get the value of y at different value of x, and x is already predefined, which is you can see here. This is the value x which is already defined. The one x is a combination of 121 values, and we get the 121 values in the y. Okay, I can also plot I can also plot the value of y with respect to x, plot x comma y, and I get the plot in. This is a example of parabola. Okay, I get the value of y with respect to x, which is a representation of parabola. Okay, so this is example how I can use the nested function inside a parent function, and how I use it with the function handle, and how I can use this explicitly. And this is how in this video you see how we can use different type of function, how I can use the function as a single input single output, how I can use the function as a single input double multiple outputs, and how I can use a function in escape file, how I can use a function with argument, and the nested function. So in this video we discuss the all aspect of function, and in the next video we'll see how we can solve the differential equation with the escape file. Okay, thank you.